OK, I'm Sriram. I work on the Windows Azure team. I'm chiefly a troublemaker over there. And for the next hour or so, we're going to have some fun digging into Ruby on Rails on Windows Azure. So first of all, thank you for showing up. Otherwise, I would have been very, very lonely. OK, so if you're here, you probably have a bunch of questions. You have questions like, what is Windows Azure? Why is there a Microsoft talk, talk from the evil empire on Ruby on Rails? Most of all, you're like, why do I care about Windows Azure if I'm a Rails developer? Impress me. I like to tell stories. I think storytelling is a great way to explain things to people. To kind of give you a sense of why I think Windows Azure is important to you as a Rails developer, I'm going to start off with a story. And like a lot of good stories, this story comes from the world of rock music. In specific, it starts on July 25th, 1965. A Rolling Stone called this day one of the top 50 greatest moments in rock and roll history. Something momentous happened that way. That day, in Newport, Rhode Island, there was a folk music festival held, the Newport Folk Music Festival. They hold this every year. And that particular event was momentous. You see, 1965 was an interesting time. There was a transition happening, a transition from the acoustic guitar-based folk music of the time to the new electric guitar-based, well, what would eventually be called rock music, but I guess at the time was called the devil's music or something worse, right? And this story has another interesting character, a very young Bob Dylan. Now, Dylan was a huge folk music star, but of late, he had been experimenting with this new electric guitar sound. So Dylan comes out on stage through this folk music concert, people who are not big fans of rock music, and he starts playing a set with this electric guitar. The place goes wild, and in a bad way. First, they go silent, then they start booing. It is a nightmare. And Dylan refused to play there for over 4 decades after that. But this moment was momentous, and it kind of heralded a change in the way American music was being performed. So at the core of all this was the transition from an acoustic guitar to an electric guitar. Why was it such a big deal? Well, it turned out that with an electric guitar, once you convert those strummings into an electrical current, you could do a variety of interesting things with it. You could distort it, you could amplify it, you could do screaming guitar solos. You could do all these creative things with it, right? Now, that was important. But more important than that was if you were a guitarist back then and you had grown up learning how to play the acoustic guitar, you didn't have to learn anything new because it was the exact same guitar. It was not a new musical instrument. So you could use the exact same skills, but you could do these incredibly creative things. For me, that's kind of the promise of Windows Azure. Okay, so you as a developer bring your existing skills in, your existing tools, your existing code, but then you come onto Windows Azure and you go into a screaming rock solo. Okay, so if you remember nothing else from this talk, remember this. Okay, the next question is, what is Windows Azure? Now, first of all, I should have asked this at the beginning. If any of you actually ever deployed a Rails app, shout out I. Okay. And do any of you actually heard about Windows Azure, played with it at all? OK, this is great. So consider this the 60-second introduction to Windows Azure. Now, I want to be clear. This is not a Windows Azure deep dive. There are great talks at MIX which go deep into all the different parts of Windows Azure. There's tons of great content on the web. This is just to give you a brief idea of what Windows Azure is about if you've never heard of the platform. Windows Azure is Microsoft's cloud computing platform. It has a few basic things. First, it has scalable computation. What does this mean? This means that at the end of the day, you can run your code on machines in Microsoft data centers. That's it. Computation inside Microsoft data centers. It's scalable. So this means that there are elements built into the platform to help you scale out and for you to demand as many resources as you want and get it. So scalable computation. Next up, it provides a bunch of cloud storage services. So any interesting happens done of data needs, be it pulling files off some SAN or a file server or a database, And Windows Azure provides a bunch of cloud database services, and all of these let you deal with massive amounts of data and do it scalably, reliably, and in a fault-tolerant way. And whether it be it unstructured data, be it in the form of blobs, or be it structured data in the form of databases. We provide a bunch of services there. Next up is pay for play. Now, imagine you're buying a new washing machine. Now, I've never bought a new washing machine, but hypothetically, imagine that you're buying a new washing machine. You don't call up the power company and say, I just bought a new washing machine, send some more juice to my house. Also, shows you I'm not an electrical engineer. I don't think they send more juice over. But you don't do that, right? You just plug it in, and at the end of the month, you get a bill for just what you've used. And you don't have to go negotiate and wait for some extra infrastructure to be set up. Windows Azure kind of provides the same promise. The idea that you pay for only what you use. And when you want resources, you get it on demand. And at the end of the month, you get a nice little bill from Microsoft, which charges you only for the resources you've used, be it for data storage, be it for computation, but only for the actual resources you've used. So everything I've spoken so far about computation, storage, this utility billing model, it's kind of similar across all cloud computing platforms. I mean, if you're familiar with some of the other players in this space, you've seen this across them as well. The next piece is something quite different. And we think it's an integral part of Windows Azure. And that is the idea of automated management. Here's what I mean. All of us spend a lot of time writing code, developing our Rails apps. But we also spend a lot of time deploying, debugging, operating system upgrades, security patches, load balancer settings, network settings, firewalls, you name it, right? There's a ton of work that we do around our code, manage, as in like scaling up, scaling down, monitoring it, and so on. In Windows Azure, a lot of these primitives are baked into the platform and done automatically for you. So this is the kind of a key differentiator between Windows Azure and some of the other platforms you see in this space. We'll touch on this a little bit in this talk, but again, if you want to dig deeper into any of these topics, I strongly suggest one of the other talks or on this website. So that's Windows Azure in a nutshell. Next up, why Microsoft on Rails? I mean, aren't we the evil empire? Don't we have a vice president in a red polo shirt who builds ASP.NET? So why Microsoft on Rails? And the answer is, we love Ruby on Rails. And we've done a ton of work to make Ruby on Rails work great across Microsoft stack. In the .NET world, we have had a ton of investments in the dynamic language runtime and Iron Ruby, which you saw about, which is I think Scott spoke about today. And on Windows Azure, Ruby on Rails runs great as well. Now, for the rest of this talk, I'm not going to talk about Iron Ruby. Iron Ruby works just the way .NET works. For the rest of this talk, I'm going to deal with a native Rails installation. The binary that you get if you go to RubyForge and download it, that's exactly what I have installed. That's exactly what I'm going to be playing with. Because with Iron Ruby, it just works exactly how .NET works. You don't need to do anything different. And it's not just Ruby on Rails that we love. Any open source language and tool that you probably use and like, we like too. By the way, that's a photo of Mads, the Ruby creator, wearing a Python T-shirt. Probably a photo I'm probably going to get a bunch of emails about after this talk. But the core principle is, at the end of the day, Windows Azure is really Windows. And Windows is an open platform. It means that Windows is great for running Java, for Erlang, Clojure, Scala, pick your newfangled tool or language, and Windows is great. And Windows Azure, at the end of the day, provides you Windows VMs. So it's great for running all these languages as well. So with that, enough talk. I'm going to jump into a demo. And what I'm going to do is to go and try and show you the quickest possible way to get Hello World working. So I have a new build of Ruby, which I downloaded a few days ago from RubyForge. And I have a reasonably new build of Rails as well. What I'm going to do is create a skeleton Rails app, right? Nothing fancy. And once, there you go. And to make sure this is, okay, what did I actually call the thing? Our talk demo. Now, what I'm going to do is just launch Webrick and it'll spin up on port 3000. There we go. I'm going to go over here make sure everything is working. Yay, this is your plain old hello world running locally on, on Windows. Pretty much something you've seen every day. OK, let me get rid of this. So the next step is to how do I get this running on the cloud? Now, Windows, by default, doesn't come with a Ruby installation, right? And it doesn't come with a Rails installation. So what you're going to have to do is to package up your Ruby and your Rails installations along with your app and upload it to the cloud. So to do that, I have Visual Studio open over here. Now, one of the goals of this talk was to show as little of the Microsoft toolset as possible. Now, there's a rich set of tools and extensions in Visual Studio to help you with Windows Azure. I'm not going to show any of that. What I'm going to show is a small little project I have, which has a bit of glue code to help Windows Azure launch my Rails app. So if I go down over here, this code is not interesting because you don't have to actually write it. See, if you look at this highlighted sentence, it's actually going to just launch script server. It's just going to launch a process. Now, this is the code we already have. This will be linked from the talk, and it's already up on our blog. So you don't have to write any of this. You can just go plug it in and go. So what this does is that it packages up the Ruby and Rails runtime along with your app. So if you look over here in the tree view, you see my Ruby folder. And this essentially, I've copied my Ruby installation with all the gems, all the binaries, and copied it in. And I also have my Rails app, which I just created, and I've just copied over in here as well. Now what I'm doing is I'm building and packaging it. And since I have over like 100 meg of Ruby and Rails gems, it actually takes a bit. So what is this building and packaging doing? Remember that I spoke about management and how Windows Azure deals with management? So the way it does that is because it has a notion of something called a service model. Instead of just saying, hey, here's the VM, deal with it, we say, OK, model your service for us. Tell us what this role does, and deal with it in abstract fashion, and specify that in a project. And once we have that service model, we can do all these interesting management things with it. We know how to scale it up, scale it down, monitor it, and so on. So what is happening as a part of this build and publish process is it's going to take all these binaries and generate like one zip file. I was stalling for time over there. Thankfully, it finished. And what you see over here, it's like this one CSPKG file, zipped is 25 meg, and this is my entire code put together. Now, it's also launched up the Windows Azure portal. This is the development portal where you can go deploy a Windows Azure app, manage it, upgrade it, and do whatever you want. Now, there's an API to do all this, but it's not so fun to demo. OK, so to actually go run this code, which I just built, all I need to do is click deploy, which will open up a file browser menu, and then point to the package. Now, when I tried this, I found that it was a bad idea to upload 25 meg over hotel Wi-Fi. So what I've done is I actually, earlier in my hotel, a hotel room, I went and uploaded the same app already to the cloud. So let me open that up. So if you see over here, you see that Azure has already allocated for me a DNS name and a URL, and it's already showing that the app is up and running. This is all like standard things in Azure. And if I go over to this new tab, if you look at the URL, it's running in cloudapp.net, which means it's running on Windows Azure. And boom, it's running my same Hello World Rails app. So it's as easy as that to actually get a Rails app working. Wasn't it fun? Thank you. OK. And that was actually the demo. So when people ask, the reason that worked is because Windows can run Ruby. OK, so people always come and ask me, hey, can language foo run on Azure? And my question always to them is, can it run on Windows Server? Because if it can, it's going to run on Azure as well. OK, so that's actually the only demo I'm going to do. And the reason is, when I was first thinking about how to do this talk, I had brainstormed something like this. I'll go over Rails feature by Rails feature, do demo by demo, and show off some canonical Rails app working, to thunderous applause and a standing ovation. But it turns out that this isn't very useful. Why? Well, we spend a lot of time writing Rails code, yes. But most of our time is spent in the rest of the stack. What stack? Well, let's start with the load balancer. You're managing pound, pen, varnish, HA proxy. You have a reverse proxy setup, which could be mod proxy or Nginx. You have an app and a web server combination, and there are a gazillion choices out there, from Mongrel to Unicorn to Thin to whatever. You have a database, which is MySQL or PostgreSQL. If you're one of the cool new NoSQL folks, you have Voldemort or Redis or CouchDB or Cassandra. If you have a distributed memory cache, which is almost always Memcached, and you all probably have a worker queue system, which is either Starling from Twitter or BeanstalkD. Now, if any of you have Rails apps which has these components, say I. OK, only 2 people. OK? So, well, the idea is that a lot of typical Rails apps uses this stack. So for the rest of the talk, what I'm going to do is not just focus on Ruby and Rails, also focus on this entire stack, so you can get an entire application and the tools and services you're used to running on Windows Azure. To start off with, I'm going to start off with the time a request actually hits our service. Start off with a load balancer. So common load balancers that you probably used to are Pound, Varnish. You probably have a hardware load balancer, which is probably quite expensive, and you have set that up. Now, the good news on Windows Azure is that you don't have to deal with any of this, because a load balancer comes as part of the platform. And we hook up your virtual machines to one of our beefy load balancers and do the routing ourselves. Like any good load balancer, it lets you load balance any available TCP port. So you can expose one IP address or endpoint externally to the public internet and have it load balance among any number of VMs internally. Oh, and you can also programmatically control it. So you can pull VMs in and out of rotation. So that's load balancers. Closely connected to load balancers are reverse proxies. Okay, people run Perlball written by Brad Fitzpatrick of ex-LiveJournal fame. People run mod proxy, Nginx, and on Windows Azure, all this works exactly the same way. Nginx works great on Windows Azure. Perlball works great on Windows Azure. So if you want to use a reverse proxy and kind of route requests that way, you can just use the exact same apps. If you don't want to, don't bother, because Windows Azure is actually by default going to load balance for you. So you saw how load balancers and reverse proxies work on Windows Azure. Up next is the core part of your app, which is the app and the web server combinations. Now, when I was doing some research for this talk and I was digging into these combinations, I found that there was a zillion options available. There's Mongrel, written by Zed Shaw, of infamous fame. There is the new cool Fusion Passenger, which has been blessed by DHH as the best way to do Rails deployment. There is maybe the new cool Unicorn from the GitHub guys. There's Thin. Some people just use mod fast CGI. And there are probably like 25 others, which I'm not there on the slide. Right? So there are tons of just options of web server and app server combination and how to set this up. And this is great, because this shows that there's a vibrant community out there just pushing at the edges. And 6 months from now, if I was doing this talk, there'll probably be 2 or 3 more out there, which probably do 2 or 3 more interesting things. Now, on Windows Azure, the good news is you can just get these apps and run them, because most of them just work. Okay, so if you're using a Mongrel cluster, just bring it over to Windows Azure and run it. If you're using Thin, just bring it over to Windows Azure and run it. So the stuff you're used to, you can just run it. Now, if you want to use IIS and the default Windows stack and the Microsoft stack, you can use that as well. So you have choices on what you want to use. Now, I say over here that most work great. And the reason I say most is because for example, Fusion Passenger doesn't work on Windows today. It doesn't compile. Okay, since it doesn't work on Windows, it doesn't work on Azure as well. Now, I don't know whether the mod Rails people are planning on fixing this, but if it's eventually going to work on Windows, it's going to work on Azure as well. But something I found is I actually went to the Rack website, and I was kind of looking through some of the popular Rack servers and frameworks, and most of them just work out of the box. OK, so what I'm next going to do is talk about a few choices you have on to how to set this up. If any of you actually deployed a Rails app in production, you're probably very familiar with this. So I'm just going to talk about how this works in the Azure world. Let's start with the simple basics. Have a Windows Azure VM. Just think of it as a Windows Server VM. There's a bit of .NET Glue code, which I just showed you. Okay? And you also have your Ruby installation, which has your server launch script. Windows Azure is going to launch the .NET code. It knows how to call into the .NET code. .NET code is very thin. All it's going to do is to go shell out to the Ruby process and start it. And the Ruby process, which is probably WebRick or could be Mongo or whatever, going to listen on port 80 and serve requests. And boom, you have an instant web app. This is exactly what I showed you in the demo. Now, the good thing about this is super simple and easy to set up. It takes literally seconds. The bad thing is it's not exactly the most fault-tolerant combination. You have one instance of WebRick running, or you have one instance of Mongrel running, it's going to crash. And when it crashes, you're going to lose some availability. So this is exactly same kind of situation people face in the non-Windows Azure world as well. So what's a more robust way to do this? So here's a more robust way. Same thing. Start with the Windows Azure VM. Same wrapper code with .NET, which is launched by the Windows Azure Fabric Controller, which in turn launches something else. And in this case, the something else is a web server. It could be Apache, could be LightTPD, could be Nginx, doesn't matter. And this web server, not an app server, is going to listen on port 80. And this, in turn, is going to round-robin requests between a number of Mongrel processes in a Mongrel cluster or some other configuration, right? So if you're outside Windows Azure, you're using a Mongrel cluster gem, and you're doing exactly this. So this works exactly the same way in Azure. So one of these Mongrel processes goes down, doesn't matter, because there are all these other processes to work with. Now, remember, all this is inside just one VM. So Windows Azure is a cloud service, right? So you can have the same configuration across any number of VMs to build a real fault-tolerant application where individual pieces can fail, but your entire service is still going to keep running. So that kind of talks about how to kind of get app and web servers running. Now, any Ruby app, any interesting Ruby app is going to use a bunch of gems, right? And you can't live without some default gems that the community uses. So on Windows Azure, what we recommend people to do is to go package the gems up along with their application. Okay, so package it up, and this is what I did. The gems are installed into my Ruby installation. I package it up and bundle it into the cloud. At runtime, if you want to, you could go shell out to gem install or do gem runner. But one thing you have to remember is that a lot of gems, well, some of the gems which require native extensions don't really compile easily on Windows, especially on Windows 64-bit. So it could be tricky to debug why one of your gems is not installing in the cloud. So that's why, at least when starting off, I seriously recommend, installing your gems locally, then publishing them onto the cloud. So that covers how you run code on using Rails on Windows Azure. Next part is data. How many of you use MySQL in some shape or form? OK, some of you. So the good thing is MySQL works great on Windows Azure. And more than that, we've actually taken MySQL, and we've put some investment into it, and we've built something called a solution accelerator. Now, this is a fancy term for us saying, hey, we have written some code to make MySQL integrate very well with Windows Azure. So it has a master-slave configuration. It can scale up and scale down. It integrates with Windows Azure X Drive. It does backups. It does a lot of these fancy things, which are probably hard for you to set up, but just works out of the box. So there's a link over there. Just go pull it. You can just use it as is, or it's a great starting point for you to modify. So MySQL works great. If you want to keep using MySQL, you can do that. But at the beginning of the talk, I spoke about how Windows Azure has a bunch of cloud storage services. Okay? So the next few minutes, I'm going to talk about each of these cloud storage services and how you can work with them from Ruby. Now, tomorrow, there are 2 talks which go into great detail on these cloud storage services. For example, one is from Brad Calder, who actually runs the storage team. So if you want to go dig deep into each of these services and how they work, you don't want to miss those talks. So the storage services I'm going to talk about today are these. First up is SQL Azure, which is our database in the cloud. Blobs, which lets you store unstructured data. Tables, which lets you store semi-structured data, which all you NoSQL people would love. And queues, which lets you send messages reliably between different parts of your application. Let's start with SQL Azure. So with SQL Azure, what we did is we took SQL Server technology, the familiar old SQL Server that a lot of people use, and we took that base technology and moved it to the cloud. But we didn't just run it inside one VM or just host it. we did a lot of work to take care of fault tolerance. We made it scalable. We made it highly available. We made sure that it makes multiple copies of every piece of data it deals with. So we did a lot of management. We figured out how to deal with provisioning and deprovisioning. So we deal with a lot of management work and take it away from you. So this is really a database as a service, not just SQL Server running in a big box somewhere in a Windows Azure data center. Now, my favorite part about SQL Azure is that it works great with all existing SQL Server code. Now, SQL Azure speaks the same binary protocol that SQL Server does. So if you have existing code or tools that work with SQL Server, they're mostly going to just work with SQL Azure. In the Rails world, you're probably using Active Record, right? And you're probably generating Active Record models. There's a nice little gem called Active Record SQL Server Adapter. And this works great with SQL Azure. So you just need to use the gem, and all your Active Record models will now use SQL Azure as its backing store. There's one little caveat. This gem, in its current form, expects a specific version string from SQL Server, and SQL Azure just happens to return a slightly different version string. So I put up this little diff over there, and you just need to patch it, and pretty soon it'll find its way into the mainline gem. So if you're going to play with it, just make this 2-line patch, and it'll be good to go. So that was SQL Azure. And SQL Azure speaks the same binary SQL protocol and works with SQL tools. The rest of the Windows Azure cloud storage services speak a slightly different language. They speak over public REST APIs, over HTTP. Now, these are just plain, simple HTTP REST APIs. They are super easy to authenticate against, super easy to kind of write code and consume. For example, table speaks atompub, and it's very familiar formats that you're used to. And since they're so easy to deal with, a lot of people have written code to deal with them. There's a ton of community-written wrappers around these storage services. If you go to GitHub and search, there's a dozen of those. I like one in particular. It's called Vaz-storage. It's written by one of our MVPs, and it provides a good set of base functionality, and it's a good starting point if you're playing with it. But again, like I said, it's just plain HTTP requests, so you can modify it, write your own, do whatever you want. So using this Vaz-storage, I'm going to walk very quickly through a few of the storage services and show you some Ruby code to deal with them. Let's start with blobs. Blobs are your giant bit bucket in the sky. If you want to store random amounts of data and have people get at it in scalable, fault-tolerant fashion, and with very low latency, blobs are for you. People use them to store large images, videos, web crawl data, any large, big chunk of data, and you can throw it into blobs. A blob can be up to 1 terabyte, and your total storage account can go up to 100 terabytes. So you can throw a really large amount of data in there. We have a CDN service, so you can throw these blobs behind a CDN service and have it cached at an edge node for even lower latency. So these are blobs. Again, there's much more complexity to them, which I'm not going to delve into now. What I want to show you now, though, is the code to deal with blobs. So we're going to use this Vaz-storage gem. I'm going to pull in the right module. I'm going to set up a connection with an account name and a secret key. This is the key that you get from the Windows Azure website. I'm going to create a container called my container. This is just a directory to hold your blobs. I'm going to throw up a blob there called myblob.txt with some random content. And that's it. At this point, there's a blob up on Windows Azure Storage. You can download it from any browser if you've set it to public access, and you're done. If you want to read it, you can do that pretty easily as well. So the idea behind this is not show you how blobs work. The idea behind is show you that these just like familiar, easy-looking Ruby code, okay? And and it's very easy to integrate with the application. It looks familiar and easy and Ruby-ish or Rubyic. I don't know what the right term is. So that's the idea behind showing all this. And I've got all the TextMate Twilight formatting in there too. So next up is queues. If you're building any large service, right? If you want to build the next Flickr or the next Mug, you have to separate out the various components of your application using queues. I mean, you can't have them talk directly to each other, because if one of them goes down, the other guy goes down as well. So that's why if you go over to Starbucks, the person who takes the order is not the person who's serving you the coffee as well. So they have two different people to do that. So that way, if they have more of a line they can just spin off more people to take orders. Or if they need more people, more baristas over there, they can spin off more people to make your cappuccino, right? So queues fulfills the exact same principle. For example, Flickr, they use queues all over the place and to kind of split apart their thumbnail generation, transcoding, other functionality. SmugMug uses queues heavily, for example, to separate their video transcoding from their front-end web servers. Twitter obviously uses queues for its PubSub functionality. In the Rails world, you might be using BeanstalkD or Twitter's Starling, and you can just use the Windows Azure queues as a direct replacement. And Windows Azure queues lets you store as many number of messages as you want, and it guarantees that the receiver is going to get your message. Okay? So let me show you, again, some very simple code to show you how the look and feel of this. Again, create a connection, same account name and secret string. I create a queue called myqueue, and just stick a message in there. And if I want to read a message back, I'd call dqueue. Right? Super easy to plug in. You can just, and you know what? Any of these services, you don't need to actually be on Windows Azure to use this. So even if you're running this in your own data center, whether you're hosted on, let's say Slice host or Engineered or anywhere else, you can just go use the exact same thing and just use the queue service from Windows Azure because it's available over a public HTTP API. That's queues. Next up is probably my favorite service among all the 3 storage services, and that is tables. How many of you have looked into the NoSQL world at all? Waldemar. Okay, few of you, right? So the principle in the NoSQL world is that you give up SQL, you give up relational database theory a bit, and you get in return you get this ability to throw massive millions or billions of entities and be able to do some querying over them, right? And Windows Azure Tables kind of delivers on that promise. The idea is you can throw millions or billions. You think of a really large number, those entities into tables, and you can do querying over them. The difference between SQL Azure and this is that this doesn't have schema. It doesn't have foreign keys, joins, all that relational stuff. This is really optimized for low-cost, really high scalable data. Now, here's a good example. If you go to Bing.com right now and do a search which pulls in Twitter results, Bing has these Twitter results, that is coming from a table storage account. The Bing Twitter guys have a direct Twitter feed, a partner feed from Twitter, and every day they throw in all those millions of Twitter messages, tweets in real time into a Windows Azure table. So I don't know how many millions of messages Twitter has, but it's a fair number, right? And that's just every day. So it's kind of a good example of a real-world usage of a Windows Azure table. Here's some sample code. Windows Azure Tables doesn't really have schema. Every entity can have its own schema. I'm a BSG fan, so I've created this entity over here with a first name and a last name property set to William Adama. I'm going to stick that entity into my table. And now that I've stuck it in there, I can do some querying. So in this case, it uses our query expression language to say, get me all customers whose last name equals Adama, and just return the top 2. Okay? And you can do some much more fancy querying over there. But again, look and feel, it kind of gives you look and feel behind the table service. Okay, so we saw how you store SQL Azure, relation data in SQL Azure. We saw how you store blobs. We saw how you hook up different parts of your application using queues. And we saw how you store semi-structured data in tables. Now, the truth is, not all applications go directly to the data store. If you want great performance, if you want low latency, you're probably using a distributed cache. You're using Memcached. Right? How many of you have played with Memcached or used it in one of your applications or deployments? Okay, there's much more people now. Okay, so the answer is Memcached on Windows Azure works exactly the same. Okay, and what we have done, just like with MySQL, is we have built these solution accelerators, which you can pull down from the URL with source and everything. And this has a Memcached setup, which integrates great with Windows Azure. And in your Ruby code, just use your same old Ruby Memcached client, and it works, and it talks to these servers. By the way, the links are on all these slides, so you can just pull out the links at the end of the talk and go download the code. Okay. So far, we have seen how to deal with load balancers, reverse proxies. We have seen how to run code. And we have seen how to store data. Okay? For the next part, I want to take a slight tangent and go into Japanese flower arrangement. This is something called ikebana, kind of a traditional form of Japanese flower arrangement. The interesting thing behind ikebana is, I'm not sure that I'm pronouncing it right, is not the flowers. These people believe that the key to these arrangements is the space between the flowers. The idea is that the space between the flowers is as important, if not more important, than how the flowers themselves are arranged. So I thought that was a good analogy for our services themselves. If you look at these boxes, right, the load balancer, the code, there's a lot of stuff happening in there. But a lot of the time-consuming tasks, a lot of the grunge work happens around it. It happens when we deploy. It happens when you get a mail in the middle of the night saying our service has gone down. It happens when we have to figure out why our network, there's no network connectivity all of a sudden. It happens in the stuff around us. So what I want to do for the last section of this talk is talk about how Windows Azure helps you with the stuff around your code and your data and helps you with these day-to-day activities. Now, for all the content so far, I spoke about how stuff works exactly the same way they work in the Ruby world. Here, it's going to be slightly different. It's going to be the way you do it on Windows Azure is going to be slightly different from the way you do it outside Windows Azure. And the reason for this is a lot of the things that you need to write scripts for or use some tool for, these are baked as core features into the platform. You just don't need them. So to start off with, I'm going to look at deployment. In the Ruby world, in the Rails world, Capistrano is widely used, right? It SSHs into your machines. It deploys scripts. It has all these fancy ways of doing upgrades and downgrades, and it's a great piece of software. On Windows Azure, deployment is a first-class item. Windows Azure knows how to deploy your application. This means you have great control over exactly how your application is rolled out. You can say, upgrade this part first, then upgrade that part and that part. Notify me before every part, or just go ahead. You can say, here's my staging environment, my production environment, just flip them over. It has all these first-class ways of dealing with deployment, again, because it knows your service model. Now, you can just use that. You can just go to the portal. You can just use the defaults. If you want fine-grained control over doing these deployment, so what you want to do is use the Service Management API. This is, again, a REST HTTP API, easy to use. It's free to use also, by the way. And this lets you manage your service. It lets you kick off upgrades, update a new package, downgrade, do a rolling upgrade, do all these fancy things. Since it's a REST API, you can integrate it with any tool. So I've seen people just stick a rake task in there and just deploy it as a part of a nightly build or something else. So you can call it from anywhere in your tool chain. So that's deployment. Next up is probably one of the most core and important features of Windows Azure, which is management. Okay? And management means a ton of things. First, it means dealing with the hardware, figuring out whether your machine just caught on fire, figuring out how to program load balancers, all that stuff. It means dealing with the operating system, figuring out how to upgrade your operating system to the newest version, or how to download the latest security update. It means managing your application, knowing when your parts of your application has gone down and bringing up a different copy in a different machine, or just restarting it, right? Doing all these activities. And all of this is baked into Windows Azure. And when I say baked, I mean there are a bunch of defaults which will try and do the right thing for you. Or there's an API where you can have explicit control over what you want it to do. And again, this is the same Service Management API. And this lets you roll out configuration changes without downtime, lets you scale up and scale down your service, lets you upgrade, downgrade, do all these things, and manage your application. Now, some of you may be using tools like Nagios and Ganglia to monitor your application. On Azure, we have a monitoring and diagnostics API, which pulls out things like CPU usage, memory usage, all your Windows performance counters, log files, all these things that you need to know to diagnose your application. It pulls out all the data, so you can just use that instead. And it does that across all your VMs in a scalable fashion. Finally, debugging. Personally, I don't have any bugs in my code. But some of you may not be as good developers as I am. Seriously. So as far as debugging on Windows Azure goes, all your standard view helpers just work great. So if you just want to do a simple printf, you can just do that. But the really interesting thing is the logger module, which is probably the way most people actually generate logs on Rails, work great with the monitoring and diagnostics API. The logger module, by default, spits out files to a logs directory. And you set up this diagnostics API, which will pull out files from the logs directory every X minutes, as you specify, and put it in a storage account. So imagine you have a service running like hundreds or thousands of virtual machines. Instead of having to run some script to rsync over log files or copy over log files, you have this service which is automatically just publishing these log files out without you actually having to go do anything. And if you want to change the schedule, you can do that dynamically as well. And this monitoring diagonal API will pick up the change in schedule and say, OK, I'm going to upload it instantly now, or whatever you want. So all the familiar debugging tools that you're used to works great with Windows Azure. So to kind of wrap up, we saw how requests are dealt with when they come in. We saw how to run app and web servers. We saw how to store data, and we saw how to do caching and debugging and deployment and management and all these other fun things that we enjoy doing every day. Wrap up, I have a few things that I would like you to remember. First off, Windows Azure is an open platform, and that means that anybody can run anything they want. Okay, and any application that runs great on Windows is going to run great on Windows Azure as well. It works great with the Ruby world. So all the tools and services and software you're familiar with in the Rails or Ruby world, they work great too. I mean, and by the way, I don't like the word the Rails world because you know what? You might be using Sinatra. You might be using camping, right? So all those things work great with Windows Azure as well. And finally, jump in. This only gets better when there's more community involvement. And a lot of this stuff I showed is just open source. So just go fork the code on GitHub, go contribute changes, go play with it, and jump in and help make this better. To close up, I want to go back to my original story about electric and acoustic guitars. I spoke about how you can do distortions and effects and all of that. But the biggest reason behind the move from acoustic guitars to electric guitars was this. They were louder. You see, with an acoustic guitar, you could only get so much volume. With an electric guitar, you could plug in these huge amplifiers and tear the roof down. Okay? So with Windows Azure, I like to think of the exact same thing. It amplifies the heck out of your application. So go home, go play Windows Azure, go do a screeching guitar solo, and go wake up the neighbors. That's all I have. Thank you. I can take questions now. Before anybody runs off, all I like to say is first, thank you for being such a wonderful, nice audience. Thank you for showing up. Take that, John Dressig, Bill Buxton. And secondly, fill out evals. Please fill out evals, and maybe next time there'll be more people showing up at talk. So if you like the talk, fill out evals. If you didn't like the talk, feel free to leave right now. OK, questions? Thank you. You can just ask the question, I can repeat it. Saves you work. OK.
I want to ask a question about the open platform.
Mm-hmm.
If just double check if I understood correctly, you suggested to deploy another web server into the Windows Azure, where basically that should be an interop assembly. Did you mean to, let's say, if it's Apache, the example you gave, you have to kind of wrap it into an interop assembly and upload into the Windows Azure?
Yes. OK.
Was possibly all complex dependencies and so on and so on?
Well, first of all, I need to make something clear, which is that you don't need to do this. By default, Windows Azure comes with IS web server stack. And if you go to any of the other Windows Azure talks, that's what they're going to show you. Now, the reason I had the interop assembly in there is because Windows Azure needs an entry point to know when to start up your application. And that entry point currently is written in .NET. Okay? And as far as all your dependencies go, all I'm doing is like the equivalent of like a sudo apt-get install. Okay, I'm just doing that, but I'm just copying it and just copying it over. So a lot of people do these rsync of binaries up to the cloud, and I'm just doing the exact same thing. And it actually works great with a lot of these open source apps because a lot of them are just very friendly to copying, and they don't deal with the registry or some of these other settings. So they work great when you just have to copy things over. So yeah, a lot of them, even with a lot of dependencies, as long as they can just copy stuff over to our servers easily, they'll work great.
Yeah, because I just remember I'm a .NET developer. I'm a Microsoft developer, not open source developer.
Mm-hmm.
And always when I install applications like Apache, SVN, and blah blah blah, there's a whole list of things you have to do manually to make them work correctly.
Well, I'm not sure because in my experience, it's not so bad. I mean, I got, like, for example, this Ruby setup working with, I think it's actually running Mongrel. It was fairly easy. I just went to Ruby Forge, downloaded it, copied it, and it just worked. I think the situation also gotten a lot better. For example, apps like MySQL, I remember when I was back in college, it used to be much harder to install on Windows. And these days, they just have a nice little one-click installer or a zip file which you can just extract out somewhere. Things are better. But you might be right. Some of these apps might be harder to install than others. But at the end of the day, they can actually launch a process on Windows, right? So you can tweak it and generate something and actually make it launch on Windows Azure as well. It may not be seamless. You may have to do some magic, but you can just make it run as well. There's no blocking issue.
Thank you.
Thanks. Okay.
Yeah, I don't know. Yeah,
I'm saving you exercise.
Yeah, okay. Well, I'm also curious about this deployment you've shown us. I mean, it looks like CGI to me. I mean, it looks like it's going to have to spawn everything from every single request. I mean, unless Windows Azure does something magic, it looks like it's going to have to go through the whole means on every single request like CGI.
Well, are you talking about the boxes I showed with the Mongrel cluster or so on? Well, okay. First of all, the reason for me to show those boxes was to say, OK, the stuff you're doing in the non-Windows Azure world, you can just port the exact same configuration over. So this is not really CGI. You're spawning it once on startup. And then in the case of Mongrel, it's speaking Zshaw's own HTTP protocol to those Mongrel processes. Or if it's mod_fast CGI, it's speaking fast CGI, right? So it's not like spinning up a new process in every request. It's a sticky process. But none of this has anything to do really with Windows Azure, right? Whatever existing web server, app server communication mechanism exists, you're just going to use the exact same thing. The point there was to show, hey, this stuff works exactly the same way on Windows Azure as well. We don't do anything worse or better in that particular respect.
Can I ask a follow-up question?
Sure.
You kind of just said you're not going to show iRuby because that's easy, that's just .NET.
Mm-hmm.
But I mean, I would have thought that was what makes sense on iRuby, on Azure to, iRuby runs regular Rails now.
Yeah.
So isn't it just much easier to run your Rails project through iRuby on Azure?
Yes. So when we do talks like this, which is
And the IIS, I mean that.
Yes. So when we do talks like this, right, which is like dealing with a non-Microsoft stack, we always have these choices. So I could show up iRuby and it works, just normally with ASP.NET, works just normally with IIS, right? But the deal is that's the exact same content you're getting from our Azure website, from all these other talks. So what I thought would say was like, hey, you know what? If you're going to use iRuby, with MVC or ASP.NET, they just work the exact same way. You can just go find some blog post and it'll tell you. But what's harder or maybe harder to find information on is how not to use, the Microsoft DLR implementations and how to run the actual open source implementations as well. The other thing is, Rails and Ruby is a fast-moving world. So, I love Sinatra. Okay, I use Sinatra way more than I use Rails, right? I'm sure there's a new framework out there, right? I'm curious to see how I'm going to port Node.js to Windows Azure. So some of those may not run on the DLR. So what I want to show is some of these basic principles where you can say, you know what, I have this cool new framework which somebody wrote, and by the way, I'm just going to use the exact same tools run on Windows Azure. It's probably going to work great on the DLR, but that's what all these other content is about. Yeah, but that iRuby and the DLR is a great way, and it just works easily and seamlessly, probably easier and more seamlessly than what I've kind of shown you here. It works great. Yes?
It's clear to me, I was most interested in the logging or monitoring API you mentioned near the end.
Mm-hmm.
Moving the log files off.
Yeah.
Would that be implemented in the worker role, or where would I?
Yeah, so first of all, there's a great talk at PDC from Matt Kerner, which just talked entirely for an hour on the logging and monitoring API. So the way it works in a nutshell is, along with your package, you upload a binary, which we provide you. And you provide a configuration file. The configuration file specifies, get these performance counters, watch these directories for file changes, get these event logs, monitor app crash temps, all that stuff, okay? Yes, so the binary spins up, and it's doing this monitoring based on the config file. If the config file says every 15 minutes, pull out logs from Rails_root $log. Every 15 minutes, it's going to pull it out, throw it into a cloud storage account. Now, the real fun part is that you can also change configuration the other way. So every 15 minutes, it's also going to check the cloud storage account for changes in configuration. So here's a canonical scenario. Your app is down, and you have just realized that the one log directory you wanted, you forgot to put in the configuration file. And you can't even get inside your web server, right? Something's eating up CPU or something. So what you do is you change the configuration in the storage account. This guy is going to pull down the changes, and now it's going to say, hey, you know what? I'm going to start pushing this directory too. Again, there's a talk which goes into great detail, on how all of this works. You should go check it out. Any other questions? OK, thank you for, oh, sorry, you have one more question.
Persistent data, it always have to be on your separate storage, or what will it work like a normal server?
Oh, yeah. These are just REST APIs. They're completely agnostic as to where you call them from. You can call them from any machine, anywhere in the world. Now, on the Azure data center, it's going to be faster because the speed of light being what it is makes it easier for network packets to go from data storage to your app. But you can call it from wherever you want. A lot of people, for example, use it to back up their files from their laptop, right, and sync it to as a storage mechanism, or maybe call it from some other hoster. You can use it wherever you want, and they work great. Like a lot of Microsoft apps, for example, use these storage services, but they don't run their code on Windows Azure, right? So it's a great way to kind of port some part of your application over and kind of use these reliable, scalable services while still running your code on some other infrastructure. They're just HTTP REST APIs. OK, that brings us to the end. Thank you, and have a nice party and have fun mix. Thank you, everyone.